So let's now start to move in the direction of trigonometric functions. We've now got our unit of measure for our angle settled. We're using radian measure. So how are the trig functions defined? Well, let's think about this first of all. Suppose I draw a unit circle. And now I look at the angle pi by 4, and I draw the line segment on the terminal end of that angle. So pi by 4 is right here. So that's pi by 4. Now this line segment is going to intersect the unit circle at some point. I'm just going to get rid of the end of that line segment. What are the coordinates of this point? If this is our x and y axes, then I want to know what are the coordinates of that point. The coordinates of this point should be a function of the angle, because given the angle, if I let that angle get bigger than pi by 4, then all this line segment does is sweep out other points on the circle. So these x and y coordinates of this point should be determined exclusively by the angle pi by 4. Well, let's see, what are those values? Well, here we're going to use a little bit of right triangle geometry. So this is pi by 4, also known as 45 degrees. What is this angle then? Well, this is 90, and the sum of the angles in a triangle have to add up to 180, or have to add up to pi. So this is pi radians. So this is also pi by 4, because pi by 4 plus pi by 4 is pi by 2, plus the pi by 2, because of the right angle there, is pi. So what I have is an isosceles triangle. Okay, what do I know about this isosceles triangle? Well, what's the height of it? The height of it is y. What's the base? The base is x. Okay, what's the radius of this circle? Well, that's 1. Oh, that's the hypotenuse of the triangle. So that's 1. So we've got a couple of things here. We've got that it's a right triangle. So we have the Pythagorean theorem that relates the side lengths, but we also know it's an isosceles triangle. So because it's isosceles, the sides opposite the equal angles are also equal. So I know that x equals y because that's isosceles, but I know that Pythagoras, I know that x squared plus y squared is 1. So I know that x squared plus x squared, or in other words 2x squared, is 1. So I know that x is 1 over root 2, which is also y. So what are the coordinates of this point? I can now fill that in. It is 1 over root 2, 1 over root 2. What about in this next example, pi by 3? So pi by 3, that's up here. That's our 60 degrees. And we want to do the same thing. We want to figure out what our y and our x values are for this point of intersection. We want to find out what xy is. So how can we do that? Well, let's draw it again. So there's our triangle. There's our pi by 3. Pi by 3 is also 60 degrees. So I'm going to write 60 in here, because I want you to be able to see what's going to happen. And it might be easier to think in terms of degrees here. So I write 60 in. That's 90 degrees. What's this angle up here? Well, that angle is going to be 30 then. What if I duplicate my triangle? Then I get this is 60. And what does this whole angle become? Well, that's also 60, because it would be 30 plus the duplicated angle, another 30, which would give me 60. So now I have an equilateral triangle, this big one here. So this is an equilateral triangle. What do I know about equilateral triangles? Well, I know that all their side lengths are equal. I know that this is 1. That's the radius. So I know that this side length is 1. And I know that this side length has to be 1. So what does that mean? Well, if this original length was x, then this length is also x. So because of the fact that I have an equilateral triangle, I have that 2x is equal to 1, or x is a half. Now that I know that x is a half, I have Pythagorean theorem applied to our original triangle. So I'll indicate that in green here. Now I've got this original triangle. And so by Pythagoras, we have that x squared plus y squared is equal to 1. Or in other words, y squared is equal to 1 minus x squared. But that's 1 minus a quarter, because x is a half. So that's 3/4. Or in other words, y is equal to root 3 over 2. And so we have that our point is 1/2 root 3 over 2. Okay. So what was the point of doing this? Well, the point was that for different angles, the terminal line segment intersects the point on the circle at different points. And so the x and the y coordinates of that point are functions of the angle. Changing the angle changes the x and y coordinates. So there's a direct functional relationship here. X and y are both functions in terms of the angle. These are what we call sine and cosine, or cosine and sine, because cosine is the function giving the x coordinate, and sine is the function giving the y coordinate. So what is the definition of the sine and the cosine of an angle? Well, if we have an angle theta, we draw the terminal line segment of the angle in standard position up to the unit circle. It meets the unit circle in an x and y coordinate. The x coordinate is what we call cos theta. The y coordinate is what we call sine theta. In other words, sine theta is this height, and this base here is cosine of theta. So sine theta, by definition, is the y coordinate of the point, and cosine of theta is the x coordinate of the point. That's the definition of sine and cosine. Okay, so this is known as the unit definition, the unit circle definition of sine and cosine. They're defined in terms of the unit circle. Given an angle, figure out where it hits the unit circle, and the x coordinate is called cosine, the y coordinate is called sine. Now, you may say, okay, so what happens in the case where I don't have a unit circle? So, in a non-unit circle, what happens in this case? So I've got a circle here. Whose radius is r. And now I take an angle, theta, and I want to know what are the coordinates of that point there. Well, it's not going to be cosine theta, sine theta anymore. We have to take the radius into account. So it's r cosine theta and r sine theta. So in the case of a non-unit circle, a circle of radius, some arbitrary r, the points are given by r cos theta, r sine theta. Okay, so we've defined these functions. Do we know cosine and sine of any particular values? Well, that was what we did previously. We just worked out that cosine of pi by 4 is 1 over root 2, and sine of pi by 4 is 1 over root 2, because those are the x and y coordinates of that point. Cosine of pi by 3 is 1/2. Sine of pi by 3 is root 3 over 2. So that's what we did here. We worked out the values of the trig functions at special angles. We call the angles 0, pi by 6, pi by 4, pi by 3, pi by 2. We call those the special angles because we're able to work out the values of the trig functions involving those angles by using either isosceles or equilateral triangles. We're able to utilize some basic geometry to get the values. For other values of angles, it's harder to work out sine and cosine for. And so there you would probably use, if they're strange angles and you just want to get an approximation, you probably use a calculator to work them out. For us, if we ever need to do these things by hand, we'll probably choose special angles as the angles we work with, just because we can work out those values rather easily. In fact, we have a whole table of values for these special angles. So we worked out a few of them already. We worked out 1 over root 2 and 1 over root 2 by pi by 4, we also did pi by 3, and we saw that sine was root 3 over 2 and cosine was 1/2. And there's similarly for these other ones. For example, what happens if the angle is 0? Always think about these things in terms of the unit circle. We're now calculus students, so anytime we think about trig functions, the unit circle should be in the back of our mind. So what's sine of 0? Well, I think about the angle of 0. Okay, so the terminal side lies right here. So here's the terminal side of that angle. Where does it intersect the unit circle? It intersects it at the point 1, 0. So this is cosine of 0, and this is sine of 0. So cosine of 0 is 1, got it. Sine of 0 is 0, got it. Again, if we're now up here, that angle is pi by 2. So the coordinates of that point are going to be 0, 1. This should be cosine of pi by 2, and this should be sine of pi by 2. And we can see that we get that in our table here, pi by 2. Sine of pi by 2 is 1. That's that y-coordinate, and cos of pi by 2 is 0. We need to know these values. Generally, when we're working with trig functions in any of our examples, we're probably going to be using these special angles. So you got to know these right off the top of your head, what sine and cosine are of these special angles. So how do we sketch the graphs of sine and cosine? Well, these come directly from the definition of sine and cosine. So let's do sine first. What do? Well, we imagine we've got our angle theta, and it's going to be moving. For this point here, what I'm interested in is the height of that point, because that's the sine of the angle. So when the angle is 0, the height of that point is 0. So there's our point. As the angle increases, my height increases. So let's jot down some particular values here. Let's say this is pi by 2, and this is pi. This is 3 pi by 2, and this will be 2 pi, and so on. So this is 0, pi by 2, pi, 3 pi by 2, back to 2 pi again. So our y value of our point increases as the angle increases. When we hit a value of pi by 2, our y value is 1. And then what happens? Then our y value shrinks and goes back to 0 when we hit an angle of pi. So it goes back to 0. And then our y value goes negative, down to negative 1, and then back to 2 pi. And it continues on doing this, similarly in the opposite direction. So it goes down to negative 1 and up to 1. And it keeps going, and it oscillates. So let's go ahead and look at an illustration. So here we've got our sine function. Remember, our sine function is going to record the height of this point. So as our angle moves, the point on the circle is traced out, and it's the height of that point that we're recording here for a particular angle. So as we go around one revolution, we've made one period of our sine function. And if we keep going, it's just going to trace out the same thing again. Up, down, up, down. So there's our 2 pi periodicity of our sine function. Every 2 pi, it traces out the same thing. And it's just recording the height of that point. So our sine function just records the y value of that point as it goes around. What about our cosine function? Our cosine function is just recording the x-coordinate of that point as it goes around. So right now the x-coordinate is 1, and then it drops to 0, and then it goes to negative 1, and then back to 0, and then over to 1 again. And we've done one full revolution, so that's one period of our cosine function. Then it just repeats. So those are how sine and cosine are defined and how we get their graphs straight from their definition. So let's go ahead and do the sketch for the cosine function. So there's theta, and maybe I'll do it in green here. So that is cosine of theta. So when the angle is 0, it starts off here at 1. And then we've got our pi by 2, pi, 3 pi by 2, 2 pi. And so it drops down at pi by 2, cosine is 0, and it goes down to -1, and then 0, and then up to 1, and then it just repeats. And similarly in the backwards direction. So that's negative pi by 2, and this is negative pi by 2. And there we go. We go up to 1 and down to -1. And so this is our graph of y equals sine of theta. That's our theta axis. And this is our graph of y equals cosine of theta. That's our theta axis. All right, so that's it for this section where we've reviewed some of the elementary functions that we're going to be using throughout the course of this term. Thanks very much for watching, and we will see you again next time.